Hello friends, welcome to my YouTube channel Make Maharashtra. In previous session we have seen the numerical solving procedure for V-belt drive. Now I'll explain you about the numerical for V-belt drive. Just read it carefully. A V-belt drive is used to transmit a power of 38 kilowatt. Power is 38. I have written here given data. From a 3-phase induction motor to a centrifugal pump, the speed of motor is 1440. Of course, 1440 is smaller pulley, that's why smaller RPM, small n. And the diameter is 225 with groove angle 38 degree. Diameter is 225, smaller pulley, and groove angle is 38 degree. Now groove angle is 38 degree. So groove angle, if they have given, it means that 25. So 25 value is something, so 5 is value we need to calculate, correct? So that will be the groove angle. Then they have mentioned the center distance between the pulley is 1 meter, that is C. The coefficient of friction for the belt and pulley is 0.2. The density of belt is 0.97 gram per cc. We can get kg per meter cube, that is 970 into 10 raised to 3. 973 will get by multiplying 0.97. Allowable tension 800 Newton, that is total tension, inbuilt tension, total tension. Determine number of belts required, Z, pitch length of the belt, and assume the cross section. This cross section they have given. So first step is write down the given data carefully. So groove angle we need to calculate. See, I told you in previous session, this will be the V belt and this is the groove angle. Actually this is 2 and at the center it means 5 and 5. So whatever be the groove angle, suppose they have given here how much, 38. So 38 means 38 divided by 2, that would be your groove angle, correct? That is 19. Okay, so these are the given steps, and of course V belt is open belt drive, open you can draw. So I'll start to solve. First we need to calculate the cross section area. You can see this is the cross section area. I can write half of top side 19 plus bottom side 9 into height 15. So that would be the your area. So same here, area is equal to half of bottom side plus top side into height, that is 210 mm square, that will be the area. Next step, to pitch line velocity. To calculate pitch line velocity, pi d n by 60 into 10 raised to 3. So 10 raised to 3 is here. So by putting this value, we will get the velocity 16.96 meter per second, pitch line velocity. Next step is centrifugal tension. Instead of mass, we had to take density into volume. So density is rho and volume is area into length, correct? Now area is directly calculated, so that area we need to use, that is rho is 970, area is 210 with respect to mm square, therefore divided by 1000 divided by 1000 divided by 10 raised to 6 into 1, and velocity we have calculated. So through which we'll get the centrifugal tension 58 point something Newton. Next part, to calculate the speed ratio through which we'll get the diameter. So speed ratio we know, here they have mentioned n by n is equal to small d by capital D. So by putting this value, we'll get the bigger diameter is 900 mm, because they have given smaller diameter of the pulley and RPM of that. So therefore the capital D is 900 mm. Now angle of contact case, angle of contact is nothing but it is open type of belt, V belt. So alpha is equal to sine inverse of d minus d divided by 2c. So d is known, d minus small d is known, and by this I'll calculate in radian 0.34. And therefore angle of contact, which we have seen in open belt and cross belt drive derivation, that is theta is equal to pi minus 2 alpha. By putting this 2.4 radian, value of theta is directly get. Now limiting tension. So here is the change. I told you T1 by T2 is equal to e raised to mu theta divided by sine of phi. So here they have given the value of 2 phi, that is groove angle 38 degree. So phi is 19 degree. So just put the sine of 19 here. So we'll get the T1 by T2 ratio is 4.51. So I can write T1 is equal to 4.5 T2, correct. So this will be the things. Next, belt tension on tight side. This is total tension is equal to T1 plus Tc. Total tension 800, permissible tension they have given, see 800. So that will be the total tension. 800 is equal to T1 plus T. Right now T1 we don't know, but here is in this equation T1 is unknown, through which we can calculate T1 is equal to 741. That T1 I will have to put here. I will get T2. Clear? These are the bed tensions. Now see, by putting this value, T2 is 164 Newton. Then next step is power to be transmitted by each belt. Now what happened in each belt? Because in case of flat belt drive, one belt is there throughout the length. So here 2 belts, 3 belts, number of belts are there. That's why each belt. So T1 minus T2 into VB. T1 we know, T2 we know, and VB. So by this way power can be calculated 9787 watt. Clear? Therefore the number of belts Z is equal to total power transmitted. Total power transmitted. Now see, they have given in the given data. Total power transmitted 38 kilowatt, correct. So 38 kilowatt divided by power transmitted by each belt. So 38 divided by power transmitted each belt, 9787. 9787. By putting this value, we will get the number of belts 3.88. So that is round figure 4 belts we need to take to sustain such kind of the power, correct. So this part is over. They have asked for the number of belt over. Now pitch length, that is length of the belt drive. Therefore I can use L is equal to 2C plus pi into D plus D divided by 2 plus D minus D bracket square divided by 4C. This is as like a open belt drive. Clear? 2C, C is known 1000, then D plus D we know, and through which we'll get the length of the belt drive is 3882 mm. Okay, this will be the second part which we have covered, this length of belt, correct. So by this way we have solved the numerical related to V belt drive. The difference is only the equation in T1 by T2. Instead of e raised to mu theta divided by sin phi, and in case of the centrifugal tension we need to take this as a rho AL. Clear? Because area we are calculated here. So I'll revise the things. In case of belt drive, you must know the cross section. Through that cross section you calculate area, then velocity, TC, centrifugal tension. Here is the important rho AL. So area is 210, we can calculate by this way, divided by 10 raised to 6 into velocity. So we'll get the TC. Next will be the ratio through which diameter we can calculate, and that diameter we can put in angle of contact through which we'll get the theta as like a open belt drive. Then limiting value, that is T1 by T2. Here just e raised to mu theta by sin phi. Phi is nothing but groove angle. So whatever be the angle they have given, that is 2 phi value, and phi value is divided by 2, that is 19 degree here. So therefore T1 by T2 value will get, and after that the belt tension, the maximum tension they have given T1 plus Tc. By putting this we'll get the value of T1. After getting T1 we can calculate easily T2. So T2 is calculated here. Now power transmitted by each belt is required, because to calculate the number of belt, so each belt is T1 minus T2 into velocity, which we have earlier calculated, and that would be 9787.3. So just put the value with respect to actual value 38 kilowatt, and by putting this we'll get the number of belts 4, and then last will be the length of belt. So as like open belt drive we have used and calculate the answer, that is 3882 mm. Clear? Likewise you should solve the problem, practice it more and more from your side. Okay, thank you.